Okay, what's up, folks? So today I'm going to start coding the joint image-text rectified flow model. I'm going to start with the training loop. This probably be like 4 or 5 videos. So 4 or 5 smaller videos. So I'll start with coding the training loop today. Hopefully it doesn't go over 30 minutes. So if you remember last time, we had this architecture diagram where I explained the joint image text rectified flow modeling objective and loss function and architecture diagram. So essentially today, what I'm going to code is the sampling of the data. So this, whatever's under this the subscript of this expectation, right? So we already have the image path where we sample the image, the T image, and we corrupt it, pass it into the UNet, and we also pass the time embedding into UNet, right? And we output the image over here. Today, I'm going to create a class for flan T5. I'm just going to use the HuggingFace interface. And we're going to sample a text. We're going to transform it into the flan T5 latent space. We're going to sample a time for text, and then we're going to corrupt the text to xtext T right here. And I'm going to add the text portion of the loss function. And I think that's it. So I'll build the flan T5 class that sets up the encoder and the decoder. I'll get the data for the text, transform it, corrupt it, pass it in, probably just make a pass through for the network, and then output vtext star and then calculate the loss function, and that'll be it for today. So let's get started. So, okay, I have this. So, okay, I'm starting with the code that I used last time. So train UNet pixel space. So in the rectified flow image only model that I made a video of, this is the code. It should be this code exactly. What I did, so what I'm going to start with here is I moved these functions, right? So like, I moved all of these functions, right? Like toGrid, right? All of these, I moved them to a utils class, okay? So that is, I moved them to this utils class, okay? And so let's put this original file over here. So this is the original file. So all these functions, I moved to its own utils class, okay? Right here. And right, so I have this file that I'm going to start working with, right? That's this file. That's all this code over here with these functions moved to this utils, right? And then I import the utils up here, right here, okay? And then you can just see me calling the TU module throughout the code, right? Compute data, right? So I moved, so it's a smaller, more compact module. And then I added comments, right? I just put like, this is the data section, and I added like little to-dos. So these are the things that we needed to do that we need to do in order to change our training code to support the text modality, okay? So so one thing I'm gonna do is we're gonna swap this, I think maybe we used the like celeb A data in the last video. I don't remember, but we're gonna bump it up to Cocoa. because I wanted to see more. One, I wanted more data, right? So the model doesn't overfit, because this is a pretty damn big model. Even though it's a toy example, the UNet's a pretty dense model in terms of the parameter space. So, and then now that we're adding text, right? So we need data that supports image and text, right? There's the Flickr 30K data set, but I tried some different models and training ones with that. It ends up overfitting. So, well, it overfit with 1,024 channels, and then I knocked it down to 512 channels, and it works well. But I'm using Cocoa 2017 data. That's what I want to use. So we need to swap that out. We need to swap that out here, and then we need to add in Flan. I did clip in another run, but we need Flan T5 so that we have a model that can decode, auto-regressively decode a latent, right? Okay. And I need to swap in the new model, the joint model here, which we're going to build in a different video. And this is the training portion. I need to do a new compute data method that accepts images and captions, like input IDs. And then we have the image modality here. We need to add the text modality, right? So we need to do, in terms of this subscript of this expectation, we need to get the text data, right? And then we need to, same thing for validation, swap it out here. And we need to, in order to prove that the text conditioning is working, I need to implement some metrics, because visually we can't see it working with, I don't know, the amount of training update steps that we're doing. We would need much more compute time. So I'm going to compute some metrics. We're not going to do that in this video. And then we need to do inference. We need to change inference to support the text modality. And that's it. Okay, so let's start with the data. I'm just going to grab this from one of my projects already. I'm not going to implement the data. You know, like if I've already showed you the gist of something, then I'm not going to do it again. I think in my clip videos, I show Flickr 30K data, which is very similar to Cocoa 2017. So in terms of its structure, it's just images and captions. So I'm going to pull this from, one of my existing files. So here you go. Okay. I also added GDrive service. So I created a module that knows how to save model parameters to GDrive instead of weights and biases. I should have done that from the beginning. Weights and biases, it takes up, I only have like 5 gigabytes of data with the free tier of that service. So yeah, that's not nearly enough. So okay. Import the data. Okay, that's good. I don't need this validation transforms. So I have my new config files, right, for this specific model, right? Live, right, boom, right here. No, this is gonna be UNet pixel space joint. All right, so let's run this. So I'm using these config files. I'm just copying them from the previous project. So it should get the data. So this Coco tokenized is just very similar to the Flickr 30K class. Essentially, what it knows how to basically knows how to read the data from the file system, parse it, and then I don't. Well, so really quickly, it knows how to read the data from the file system, parse it, and then the get item. When the data loader, when we're iterating over the data loader, right? It knows how to return an image caption in terms of input IDs and attention mask. Okay, so what's wrong here? Right, that class doesn't exist. Well, what's going on? Train utils. Okay, I can close this. I'm gonna close this now. We're just looking to see if it lands on this breakpoint without erroring. Oh, I need to authenticate with Google. So let's run the main method in this GDrive module. Boom. It pulls up a screen to authenticate. Google hasn't verified this app. Yes, it has. I don't know why it's saying that. Let's run this again. So it puts this, okay, it hits the breakpoint. We're good, no errors. So that means the data set and everything's okay, which is as expected. So when I authenticated with Google, it places this token JSON in the project files. And it uses that once you authenticate, and it uses that to verify that you're authenticated. So, okay, now we need to implement FlanT5, the FlanT5 class. So I just have it stubbed out here. So essentially we need to do the constructor, right? So super.init So essentially what I need to do import auto auto tokenizer, auto model for sequence to sequence LM. Okay. So we have an interface for a tokenizer. We have an interface for a sequence to sequence model, language model, right? And I'm going to say self.tokenizer equals auto tokenizer dot from pre-trained, right? From pre-trained, and then we're going to pass in the model name, and we're going to say right, and then self dot model is auto model from pre-trained, right? In both cases, model name. And in both cases, this is going to be Google Plan T5 small. I guess this device will be I'll just say it's none. And then we're going to do to device. Let's just make sure that none of these parameters are set to update. P.dot requires grad false. Okay, that's the constructor, and then now we need to create the encode function. Okay, so it's going to be self dot. I think we can just return self dot model dot encode. Input IDs, attention, mask, return, and we want to return a dict. I want to return a dictionary, and we're going to return the token embeddings. Okay. So we can format this. All right. And then so decode, once we have, once we transport the text latent, once we perform inference and we transport the noisy text latent to an actual generated, to the data distribution, right? Then we can pass that into the Plan T5 decoder. Okay, so if attention mask is not none. So we need to generate, okay, so we need to, we have this transformers base model output, right? So it's another, you can consider it an interface, right? We need to, we're gonna call, okay, so we're gonna call this self.model.generate. It's gonna take this encoder outputs. So this is going to generate token IDs, and then we're going to use the tokenizer.batch decode to batch decode. We can just call this gen IDs. I'm kind of doing this backwards, but it helps me remember what I'm actually doing. So attention mask, max new tokens, num beams. I don't know why autocomplete isn't working. So okay, so this encoder output, right? It needs to be, we're going to use this interface base model output, right? It's a class that the generate function knows how to interpret, right? So we're going to give it these encoder hidden states, right? We pass it, right? We're getting last hidden state, right? We're returning last hidden state, and then we're gonna transport the data in this space where last hidden state exists, right? And then when we transport the data to the distribution, it's still in the shape of last hidden state. We wrap it in this base model output just so this generate function, because generate function is expecting something that looks like this, right? And we pass encoder hidden states in, we get these encoder outputs, and then we pass it into the generate. So then this generates token IDs, and then this tokenizer we call batch decode to decode the token IDs into actual sentences, okay? So that's our flan T5. That's our flan T5 class. All right, so from rectified flow, live, encoder decoder, flan T5, boom. Model name equals token path, flan T5 small. Device equals device, boom. Okay. Now we need to swap out the text conditioning model. So, okay, we have this UNet pixel space. So we're going to change this. We're going to change the name of this to UNet pixel space. Or I guess, I don't know, we can just call it UNet yeah, I don't know, UNet pixel, we can just call it UNet-joint. Okay, cool. All right. So yeah, we're not gonna worry about that too much for now. Let's just change the forward method. Okay, let's do a couple things here. Let's change the forward method. Okay, so we need to take in t-text, t-image, and then x-image-t and x-text-t, right? So we have x-image-t, t-image, x-text, t-text. Okay, that's what we want. Yeah, let's just do that for now. Okay. And then we need to return, okay, so, okay, we need to return, okay, so we need to return, okay, so we have, Cocoa tokenized. So we have this new Cocoa tokenized class, right? That returns image input, images, captions, and attention masks. Okay, so here we're going to return images, captions, or input IDs, attention mask. Okay. And then we're going to do the same here. And now we need to do a new compute. So how about we just place a breakpoint here first and then just make sure the constructor, make sure we have no errors in the flan T5 data class for the data loader. Yeah, it looks good. So images, shape, input IDs, shape. Yep. Attention, mask, shape. Yep. Okay. This looks good. All right, so now we need to swap out, we need to do a new compute data class, right? So we're going to say compute data joint. I guess we could overload it, right? But anyways, okay. So we're just going to do, so we have, we have an image path, and now we're going to make a text path. Okay. So okay, so this is going to take in images, input IDs, attention mask. Okay. Actually, let's do this first. Let's say X image 0, X image 1, T image, X image T, V star image, V pred image. Okay, right, so we have the data sample, X image 0. Then we sample, we sample noise, right? X image 1. And then we sample time uniformly, T image, and then we corrupt X0. We corrupt X0, right? And get this X image T, and that's what we pass into the model. And then here, we're gonna move this model down here. And then we're gonna return V star image, V star text, V pred text, okay? So now we'll uncomment this. We'll say X text 0, X text 1, T text, X text T, V star text, and this is going to be V pred image, V pred text. And then the model is going to take in image text, so image text, T image, T text. Okay. Okay, and then the image, the input IDs. This is, just say this is L, which is 77. And now, okay, now we need to flan T5 encoding. So we're gonna do so we need to pass in our encoder decoder. Images, input IDs, attention, mask. Let's put model at the beginning. Let's do model, then encoder, decoder. Yeah. Yeah. Okay. So flan T5, this is going to be encoder, decoder. So we have, actually here, let's do this. Let's do this. Model is UNet, pixel space is UNet-joint. Encoder, decoder is flan T5. Images, torch.tensor. Torch.tensor. Torch.tensor, so we can use completion. Torch.device. And then we'll format, okay. Then we'll import. Oh. Wait. What happened? And then we'll so I actually modified the wrong class. This is UNet pixel space live. I want to do UNet pixel space joint live. And let's go here. Wait. Okay. UNet-joint. Okay. So I was modifying the wrong file. So UNet pixel space joint live. That's what I wanted to modify. So, you know, we turned the UNet into UNet-joint, and then I just added this, the text t, x text t, and t text to the forward method. Okay. And then back to our train utils. So compute data joint. So I was formatting the file, okay? And I basically was adding these type declarations so that it makes it easier to, so I have code completion, okay? Yeah, so I have this encode method. So I'm encoding the text, right? So encode, it takes in input IDs to device. I sent them to the device, yes. Actually, is that T5? No, I'm not doing it in this method. Okay, good. I don't want to repeat code. Okay, so I'm returning last hidden state. Oh, wait a minute. Rectified flow, live, encoder, decoder. So, okay. Oh. Returning last hidden state. So, I don't know, what do we want to call this? Last hidden state. And then we also want to send this to the device. Okay. All right, so this is going to be of shape BL what do we call this? Text hidden TH. Whatever, I think it's 512. I think for T5, the token embeddings are 512 dimensions. I believe so. Okay, so then this is now this. How about we do this? Just, we're only using B once, so we do that. do that, clean it up just a little bit. Okay, and then, so this, we're gonna remove those. And then the time shape, so it's gonna be that, boom. Okay, and this is gonna be TH, okay, it's good. Boom. Okay. All right. This is the same shape, BLTH. Right, okay. I think this looks good. So it looks very similar to the image, except we take the text and we pass it through the, oh wait, this is not X text 0, so this is LHS. So this needs to be, yeah, this can stay the same, but this needs to be like LHS. Okay. All right, so this looks good. So let's you can delete that to do. You can delete this here because we're doing it now. Then we can place a breakpoint inside here. This should all be good already. And then let's just go right here. See what happens. Okay, let's test this out. Okay, so X image 0 dot shape. Yep, looks good. Right, and now we have the batch size is 2 because in our config file, our local config file, which is what we're running, batch size is 2, image size is 32, right? Okay, cool. So I forgot what file we're in, so let's just go straight to the thread. Okay. Okay, right, so 2, batch size is 2, channels 3, 32 by 32, yeah, that looks good. X image 1 should be the same. Yep, okay. T image. T image, I was like, wait, hold up. T image, yep, should be a batch size. Okay. X image T, X image T dot shape. Yep, that looks good. V star image dot shape. Yep, that looks good. Okay, let's look at the text. Should be the shape, same shape as input IDs. Yep, okay. Now, okay, so let's step into this. Well, we can just step over it. I mean, Encode is just going to call the model. It's going to call the tokenizer interface. It's going to call the model interface. It's going to send it to the FLAN T5 encoder. Input IDs, attention mask. Wait a minute, did I send attention mask to the device? No. Let's do this explicitly, just so it looks orderly. images dot to device input IDs dot to device attention mask. All right, let's kill this. And we're just renaming it here. Input IDs. Okay. Yeah. This is cleaner. So let's restart that. I needed to make sure the attention mask was on the encoding of the text. It should just return the last hidden state. So we should see 2 by 77 by 512, or whatever TH is. Nope, doesn't like that. Attention mask. Okay. Doesn't like it. T5 for conditional generation has no attribute encode. All right, let's take a look at this. Oh, right, I'm calling the forward method of encoder. All right, no errors. Yep, 2 by 77 by 512. This is correct. It doesn't like this. What's going on? Must match the size. Size of tensor A77 must match the size of tensor B at singleton dimension 2. Wait a minute. T-text, x-text 0 dot size. Wait a minute. T-text dot shape, x-text 0. Oh, okay. Yeah. Okay. Send the input IDs to the device. Okay. Then I'm going to encode the input IDs and get text tokens, and then so we can just call this x-text 0. Okay. And then x-text 0. Okay. And yeah, this should be correct. Okay, it looks like it doesn't have any error, so x-text t. Yep, that looks right. E star text. Yep, that's right. So, okay, so that works. Now let's just do a couple of more things. We're gonna go to the model. Because now we're returning vpred image and vpred text. So I'm gonna add a dummy text head, right? So we have this. Out, and then I'm going to do text out. text out projection, image out text. Okay, so it's gonna be so I want to return something for the vpred text. I think so let's just so for this text out projection, let's do this. All right, so this is what we want to do. Let's actually just, okay, let's do this. Let's just implement class text velocity head module text dim image dim hidden. We can fill in the details of this later, or the actual numbers later, but let's just start with those for now. Text in, we're gonna add, okay. Do sigmoid linear, and then back to the text dimension. So basically we need, okay, so we need to, all right, this isn't gonna make too much sense now, but actually, you know what? Let's just do this. Let's just do this. Let's just do this. It's not going to be a joint model yet. Let's do this. Yeah, okay. Let's do this. Let's leave this here. Let's do this. Yeah. Def forward self x. Okay, yeah, let's do that. And this is going to be leave all that the same. So we'll leave that blank. Actually, T5 dim is 512. Just leave that there. And then this last layer is just gonna take in X text T. So it's nothing joint, right? No combination of image and text. I think it's 77, but we'll just say it's L for now, 512. Okay, okay. Okay, let's see what happens. Okay. Okay, let's step into this. Yeah, this is all gonna be good. Image out, boom, and then text out, boom. Okay, so now it returns, boom. Then we're gonna return all of that, oh, boom. Okay, looking good. So let's turn the debugger off. So this is gonna be v image star v image or v pred star. What did I call it? V star image, v pred image, v star image, v. Okay, and then star text v pred text. Format that. Okay. That's good. We'll swap that out there. Should be good. Now, okay. Now let's just quickly do the loss function. So we'll say loss image, loss text, okay. Image plus loss text. Oh. Yeah, okay, well. Yeah, let's just, okay. Loss plus loss text dot item. Oh. Loss image plus loss text, loss backward. Okay. Yeah, that's our loss. All right, let's run this. Make sure it can run through. It's not going to be correct, of course, but if it runs without any bugs, we'll wrap up the video and call it a success. Call it configure data twice. Configure data. So we have the squared L2 norm of loss image, squared L2 norm of loss text, add them together, right? And that gives us this loss. Cool. So it looks like it's running through. no issues. Let's make sure the validation is good. It's cleaner if I do this. Yep, looks good. Okay, that was way longer than I expected. It's probably an hour, unfortunately, but all right. Yeah, this is the training loop for our joint rectified flow model. Yeah. Next time I'll start coding the actual model, and yeah, we'll keep it moving. Thanks for watching.